This video is on the definitions of motion along the line. Now it's going to be a different video than the majority of the other ones in the sense that I'm not going to solve any of the problems that I put up. What I'm going to do is have you guys copy these definitions and also these examples into your notes. And then in class, I'll do a demonstration through the GeoGebra and then through your graphing calculator of how these problems kind of look and what they kind of deal with. So this topic lends itself to more of the traditional type of lecture lesson. So I'm not going to be able to do it through the online videos, but this is just to get you guys prepared. So I'll be checking that you guys have these outlined and these definitions in your notes, and then in class we'll go ahead and solve these problems. The first set of definitions deal with the equations we're going to be talking about. If you're given a position of a particle, the first derivative of position is going to be a velocity. And if you take an additional derivative, that's going to be acceleration. So you have position, velocity, and acceleration. This is a function. You can think of this as the first derivative, the second derivative of position. You can also think of acceleration as the first derivative of velocity. And we'll discuss this further in class and deal with this throughout the entire school year. And then the units of measurement, if you're given position to be a distance, for example, this could be measured in meters, maybe it could be measured in feet. Then the units for velocity is going to be the distance over the time. So this is going to be like meters per second, or maybe miles per hour, feet per second. Acceleration is going to be the distance over the time squared. So this could be meters per second squared, miles per hour squared. So whenever you have acceleration, the time measurement is squared. Next set of definitions deal with direction. If your velocity is positive, that means you're moving to the right. So we're going to say the particle moves to the right. If velocity is negative, particle moves to the left. Sort of think of it like on a number line. If you're to the right, you're going positive. If you're to the left, you're going negative. Particles at rest, if your velocity is 0. So resting means you're not moving. So if you're not moving, your velocity has to be equal to 0. And the particle changing direction means that the velocity has to change signs. So either switching signs from a positive to negative or negative to positive is required for your velocity to, for the particle to change direction. Last set of definitions deal with speed. Speed is just the absolute value of velocity. That's why on your car it's called a speedometer, because it's measuring the speed. It doesn't matter if you're going in drive or reverse, it's measuring the speed because it's just telling you, your speed basically. Speeding up and slowing down, I'll have to explain this further in class definitely, but if your velocity and acceleration have the same signs, you're going to be speeding up. If velocity and acceleration have different signs, you're going to be slowing down. And then in class I'll do a little demonstration of what this looks like. Alright, as far as the examples, I'm just going to put these up here for about 3 or 4 seconds. You can pause it, copy these down into your notes. There's a part C to this, so at this point you can pause it so you can copy A and B. And then here's part C of example 1. And please leave enough space where you can work out the problem. I would say maybe skip maybe 4 or 5 lines in between each letter, because it will take a little bit amount of work. So about 4 or 5 lines between each part. For example 1. And here's example 2. There's part C also for example 2. So again, skipping about 4 or 5 lines between each part, so you can work these out. And here's part C. And that's it for this video.